Finding the derivatives of functions part 1. We are now getting into the main arena of differential calculus, the main arena of getting the derivatives of functions. Last time we showed to you a few of the rules to get the derivative without using limit. So this is only part 1 wherein we shall show how to get the derivative of functions using the rules that we spoke about in the previous videos. So when we have a constant function, f of x is equal to c, the derivative of that function with respect to x is just equal to 0. When our function is a simple linear function, f of x is equal to m times x, f prime of x is just the slope of that line, and it is equal to m. When we have a function f of x is equal to x raised to n, the derivative of that function with respect to x is n times x raised to n minus 1. Some books call this the power rule, but we are not yet giving these techniques names. Okay, so what we do now, or what we had been doing, is we are looking at the types of functions, and we are showing to you how to get their derivatives with respect to x. Product of a constant and a differentiable function. If capital F of x is equal to a constant times a differentiable function f of x, the derivative of capital F of x is equal to c times f prime of x. Sum or difference of two differentiable functions. When our function is the sum or difference of two differentiable functions, the derivative of that function, capital F prime of x, is just the sum or difference of the derivatives. Example 2.13, applying the rules on derivatives. Get the derivative of each function with respect to x. So let's say, for example, f of x is equal to 3x minus 7. So this one is a difference of two functions. One is constant and the other is a simple linear function. And so the derivative of 7 of a constant function is just 0. The derivative of 3 times x with respect to x is equal to 3. And so f prime of x is equal to 3 minus 0, which is equal to 3. Okay? So this is just the result of your sum or difference of two differentiable functions. G of x is defined in the following way. It is equal to 3 times x cubed minus 2 times x squared plus 2/3 times x minus pi. So this is the sum and difference of many functions. So for the first term, it's going to be, okay, so this is a constant. We will just leave it as it is, 3. So 3, we will bring it down. Look at that one. And then we will subtract 1 from the exponent of x. So 3 minus 1 is 2. So the derivative of the first term is 3 times x squared. Now let us go to the second term. Again, we just leave 2. And so we will bring down 2. And then we will subtract 1 from the exponent of x. 2 minus 1 is 1. And so the derivative of our second term is this. You can look at this as a simple linear function, and the derivative of that with respect to x is just 2/3. This one is a constant, pi, and the derivative of that with respect to x is just equal to 0. Okay, so g prime of x is equal to 9 times x squared minus 4x plus 2/3. Find the equation of the line that is tangent to this curve. Y is equal to 2 minus x squared at the point -2, -2. Let us look at the curve and let us look at the line that is tangent to the curve at the point -2, -2. So the red curve is our parabola that is defined by y is equal to 2 minus x squared. Point A is the point with coordinates -2, -2. And that is our tangent line. The blue line is the tangent line. So the question is, or the challenge is, what is the equation of that tangent line? So how do we get, or how do we write the equation of a tangent line? Well, there are many forms to getting or to writing the equation of lines, but we can use point slope form. Why? Because we are already given the point. That is the point. Now, what is m? M sub t of L. That is the slope of the tangent line. Well, the slope of the tangent line is the derivative of our function when x is equal to -2. Okay, so that is how we shall write the equation of the tangent line. We will need the slope of the tangent line, which we shall obtain from the derivative of the function when x is equal to -2. First, we get f prime of x. So where did this come from? Where did -2x come from? It came from this. So this is, you can look at this as a sum or difference of two differentiable functions. The derivative of 2 with respect to x is 0. The derivative of that with respect to x is equal to, okay, so you will bring down 2 and you will subtract 1 from the exponent. 2 minus 1 is just 1, and so that's it. It is equal to -2 times x. That is the general derivative of the function that is defined by the curve y is equal to 2 minus x squared. So what exactly is the derivative of our function when x is equal to -2? So you just evaluate f prime of -2. It is equal to -2 times -2, and that is equal to 4. We now have the slope. We also have the point. We are given the coordinates of the point. And so using our slope point form or point slope form, this is how you write the equation of the tangent line. Okay? So y sub 1 is -2. So y minus -2, okay, it becomes y plus 2 is equal to, okay, so y plus 2 is equal to m is equal to 4 times x minus x sub 1. X minus x sub 1 is equal to x minus -2, and that is equal to x plus 2. And so this is the equation of the line that is tangent to your curve at the point with coordinates -2, -2.